Morning, everyone. I hope that you guys are having a good start to your Tuesday. Thank you guys very much for coming to class. I'm going to minor adjustment to my volume. Then I'm going to do some things on my computer that I'm in the process of closing some things. Then okay, full screen. Right. So we've got exam number 2. Now, I'm not sure if everyone had the opportunity to read the message that I posted last night, but I'll go ahead and summarize that again right now. So our exam, well, the first things that you need to know about your exam are that number one, the exam will be proctored using Proctorio, just like the last time. Um, it will be a good idea for you to go ahead and use the Proctorio practice quiz, which I'll grab the link for that right now and copy that into the chat. So there is one Proctorio practice quiz that is open, and it will be open through the rest of the semester. The reason for this quiz is just, to confirm that you're good to go. Let me grab the link. Proctorio practice quiz. And published. Do those. I want to save that. Copy two. Where's my link? Where's my link? Hmm. Um, could I get somebody to follow this link and confirm that they see a quiz titled Proctorio Practice Quiz? Um, yeah, could you just confirm in the chat, Y or N in the chat if that link works for you guys? Great. Thank you very much. So please take the opportunity to do that quiz just to confirm that Proctorio will open for you. Um, I know that there were some folks who they had issues last time, and that's stressful for you. It's stressful for me. And I'll be frank, it's also kind of frustrating because, this link has been available. So if you're in a situation where you're like, oh, well, my laptop's at the shop and it's not ready, I'm going to use my buddy's computer. Make sure that that buddy is aware that you're going to use their computer. Make sure that you're all ready for that, as opposed to like sending me an email at like 11 a.m. on Thursday and saying like, "Oh, I can't find my friend," um, because that's something I can't help you with in terms of like tracking down your friend. Okay, so please do that before Thursday. The sooner you do that, the better. If you encounter an issue with that, please contact me so that I can do what I can to try to help you resolve that. Um, So wherever you're taking your exam, just make sure that you are ready for that. You've got everything set up. And so go through that. Now, the next thing is I'm making a little bit of a change. I'm going to have the exam open at 8 a.m. and close at 12 p.m. And what that means is it will stop. It will shut down at 12 p.m. I know that last time, and I want to avoid this confusion, last time there was like, it was late after a certain time. I'm making the due date and the closing date the exact same, just to alleviate and to remove any sort of confusion. The next thing is that you will have 60 minutes for this exam. The exam will be a grand total of 40 questions, and I'm still revising the final draft, but what it's looking like is between 28 and 30 questions. Sorry about my writing there. QUESTIONS Questions are the new material. And if you're thinking, well, where am I going to find that new material? That new material is on the slide decks that are week 6 through week 8. Each day there were two of, or sorry, each week there were two. There's week 6, day 1, week 6, day 2, week 7, day 1 and 2, and week 8, day 1 and 2. So those are the slide decks that you want to look through for your so-called new material. And those are the slide decks that I use to make the practice exam that I posted. So this right here is mostly what you're going to see on your practice exam, if you haven't already looked at that. So then a fair question is, well, what about the other 10 to 12 questions? Or, yeah, 10 to 12 questions. I'm going to say, let me rephrase that, 28 to 30, 10 to 12 questions are your so-called old stuff. And if you're thinking, okay, well, it's been a minute since I've thought about that. Well, some of the things that it's all of your older slide decks, but also this is a lot about physical and chemical changes, as well as like density and then calculations related to density and observations related to density. Um, Basically, if you're thinking, oh, well, how am I going to study for this stuff? Review your old exam, which I'm not sure if anyone has looked, but if anyone has, could they confirm with like a 5 in the chat that, yes, I looked at my old exam and I could see my old questions and I could see the correct answers. I know that there were folks asking for that a couple of weeks ago. I believe that I made that change, um, and nobody's asked me since, but I'm not sure if anyone has taken a look at that. If anyone in here has taken a look at their old exams and can confirm that they see their old exams, add a 5 to the chat. If I don't see a 5 in the chat, then that's going to mean that I must not. Okay, I see, Angel. Thank you very much. So those are your best resources. And if you're thinking like, well, are these going to be good resources? Like, I'm going to go to how should I triage? Is everyone familiar? Give me a Y in the chat if you're familiar with the term triage. Okay, so uh I got two private messages. Where do we look for the old exams? The old exams, I believe if you click quizzes, that'll take you to there. And then I got a private message. I could not because I have an iPad. I'm not sure what that's in reference to, if that's in reference to looking at old exams or taking the exam. If that's a response, or if that's a comment regarding taking the exam, then I think we'll probably have to communicate maybe during office hours or something, right after class. My test says locked and just shows my grade. Okay. Well then I'm gonna make a note to myself. Um, I'll say 1310 exams. Make available. So I'll take a look at that. You can find the exam through grades or assignments as well. Okay, thank you very much. So I will get to the bottom of the old exams and make sure that everyone can see that. And you know what I might do is just export a PDF and post that up. That would probably be easier. Oh, thank you, Zach. You have to click on submission details. Okay, this is awesome. This is community supported here. Okay, so triage your studying. If I was going to triage my studying, what I would do is I would take, hmm, I'd look at my old exams first. And really what I would do in terms of like, you have 40 questions and 28 out of 40 are new. The first thing that I would do is I would look at my practice exam. I'd look at my practice exam and basically say, do I understand this question? Do I know the answer? I'm going to post the practice exam key a little bit later today, so you'll be able to compare that as well. But I'd look at my practice exam and see how I feel about that. Then the next thing that I would do is I would go on to my old exam. And I would look at all of those questions and say, okay, were there points where I had strengths? Were there points where I had weaknesses? Where am I? How do I feel about this information? And then after that, so the third place that I would go is new slide decks. And then the last place is old slide decks. So that's kind of where I would go if I were doing this, if I were preparing for this class or preparing for this exam. Um, that's like that's the sequence that I would follow. Now, with respect to what should you guys expect on the exam? Like I said, 40 questions, and they are all multiple choice. Oh, Kelly, thank you very much for answering that. Um, so all multiple choice questions. Kelly's question here is about the homework. What I'm going to do with respect to the homework is, and actually, I think I think what I would do is actually I would insert right here homework because that homework is going to be good for confirming that you're good with respect to the practice exam. Um, I'm going to push the homework back to be due on, well, tomorrow night. So that would be 10/22 at 11:59 p.m. Now, like I mentioned last time, the key will be available. I know, Kelly, you're asking about sorry, I skipped over the word key answers. The key, and I just got a private message about the exam dates. I'm going to get to that in just a second, so I appreciate your patience on this. The key will go up. I'm going to say key goes up basically at 10:23, 12 a.m. So midnight. So like a minute after this, the key will be posted, or the key will be available for you. Um, okay. Now, before I start talking about exam dates and when you can take it, um, does anyone have any questions about this right here? Any of this stuff right here? Just confirm that you don't have any questions with a um, N in the chat. No, no questions. Okay, great. Okay, so the next thing that I wanted to talk about, and just so you guys know, um, your homeworks, you can make as many submissions as you want. The latest one or the most recent one is the one that I will grade. Like if you have 55 submissions, the one that I will see, I can look through all 55 of them. I have no interest in that. The one that will come to me is the one that has most recently been submitted. Okay, now the next thing that I wanted to talk about is the big question of when to take the exam. To take the exam. So I know that some folks, for whatever reason, they've looked, well, not for whatever reason. But, you built your schedule. You saw when the exam was scheduled, the 23rd, and you said, okay, cool. Well, I can set my work schedule around that. I can set this schedule around that. I'm going on vacation. I don't know, whatever. Um, you can take the exam 10/23 from or between, let me rephrase that, between 8 and 12. This is 8 a.m. and 12 p.m. So you have a 4-hour window in which to take that 1 hour exam. You have 1 hour, so whenever you start, if you start at 11 a.m., that's basically the latest that you can start and still have that full hour. If you start at 11:45, it will close after only 15 minutes. So do not start at that time. Um, so that is one option. The other option is, and this is Thursday, 10:28 between 8 a.m. and 12 p.m. This is this upcoming Tuesday, so 1 week from today. If you have a little bit more flexibility in your schedule, great. If you do not, and you have to take it on Thursday, I understand and respect that. Now, what I want you guys to know is that the exams on these two dates, they will be different. They will be covering the same content, though. Now, in addition to that, you can only take it once. So let me put a big OR. So if you take that survey and you say, oh, I want to take it on Thursday, I'm going to sign you up for Thursday. Now, if you don't show, then I will move you to Tuesday. I'm not going to be like, oh, well, you missed your chance. There's no other chance. I'm just going to say, okay, you signed up for this, but something changed. If we do the exam okay, I got two private messages. I'm going to answer the most recent one first. The most recent one is, when's the survey due? The survey, so basically make your decision, survey by 10/22 at, I think I've got it at 5 p.m. Basically the end of the kind of workday. So that then I can distribute everyone and assign them the exams. The next question that I got, or the previous one that I got, was if we do the exam on Tuesday, does that mean there will not be a class on Tuesday? I'm happy that you asked that. What I am going to do, so actually, I, JWG, Joel William Gray, will teach and record the same content on Tuesday, the 28th, and Thursday, the 23rd. So I got a private. So it's possible that I will show up to teach that tomorrow, not tomorrow, on Thursday, and no one will be there. And that's fine. Um, just a second before I. Okay. So how I wrote them? No, I just wrote them out of sequence. Sorry about that. I got a private message. Thank you. You're right. I need to erase this. I need to change this. I will teach the exact same content on Thursday, the 23rd. I'm erasing. So the day after tomorrow and Tuesday, the 28th. So 1 week from today. Now I got a private message that says, will the survey be on Canvas? Yes. The survey is on Canvas. It was in the announcement that I sent yesterday. It's also right there on that link. So all that I need you guys to do is answer that. And if you say you're taking it on Tuesday, great. If you say that you're taking it on Thursday, great. If you take it on Tuesday and want the live lecture, I will be giving that lecture this upcoming Thursday, the 23rd. If you take the exam on Thursday, then I'll give the exact same lecture, the intended lecture, on Tuesday, the 28th. So I'm not going to be giving any sort of additional review session or anything like that. So I want to make sure that as I want to make sure that there's basically no advantage that anyone's getting by taking it on a different day. Will the content on the Thursday class be on the exam if you take the exam on Tuesday? No. Thank you very much for asking that. Let me go ahead and add that detail. That's an important thing to include here. This will be, there we go, will be new material that will be for exam 3. And the final, obviously. Well, I got a private message that says, can we use the note card during the test? Yes, you can. You can use a note card. Important information, though, is that there's only one note card. So that note card has to have all of the information that you want for exam 1 and exam 2 material. Okay, now are we allowed to use blank scratch paper? Absolutely. I will enable the calculator, so if you're taking it on Canvas, you'll have the calculator. You got a private message. Okay, so to clarify, we can choose either Thursday or next Tuesday to take exam 2, 100%. It is 100% your choice. There's no this isn't any sort of like, I don't know. I'm not really just giving you guys the option. If it's better for you to take it on Thursday, take it on Thursday. If you feel like having the full weekend to look at stuff would help you more, then take it on Tuesday. And if we pick Tuesday, we join Zoom on Thursday. At that Zoom, yeah. I mean, I'll treat that kind of like a regular class period. Sure. Okay. Um, does anyone have any questions about like the logistics of the exam? If you do not have any questions, please add to the chat N. At that point, once I see a bunch of N's and no other questions, I'm going to go ahead and start working through some of the homework because the homework is intended to be kind of a review, which is why I toggled it back to being like the second thing that I triage. So for attendance, great question. We have to attend at least one of the classes. For this Thursday and this upcoming Tuesday, I'm not going to be counting attendance. I'll do Zoom questions or not Zoom questions, Zoom poll questions, um, just for like participation, see where people are. But it's not everyone's going to get attendance for those days. Okay. If you submitted the survey but want to switch the date, can we still switch it? I believe that you have two attempts at the survey, but if not, let me go ahead and make that change. I'll edit the survey so everyone has like three tries so you can resubmit it. Oh, no, you have two attempts, so you can switch. But I'm going to assign you based on what you submit before 5 p.m. tomorrow or after 5 p.m. tomorrow, because that's whenever it's due. That's when I want to see that information. And then I'll send out a note and I'll say like, hey, this is based on the survey results. Um, if you see yourself on the date that you do not want, please contact me as soon as possible. If I don't hear from you, then I'm going to default to put you on Thursday because that's when the exam is scheduled for. Because I'm sure that there are some folks who aren't in class today and maybe overlooked the survey and overlooked the announcement, and they know that they have an exam on Thursday. And so they're probably ready for the exam on Thursday. Or if they're not ready, they kind of resolve to, well, that's when I'm going to take the exam. So that's kind of a good point to like pay attention to announcements and whatnot. Okay. Well, since I've seen a bunch of N's in the chat, I'm going to go ahead and proceed, and I am going to work through some of the homework problems. So what we have are basically homeworks 2, 3, 4, 5, and 6. Now, homework number 2, that's where I'm going to start. These all highlight important things. So homework number 6 says, draw the Lewis dot structure of SF6. Clearly include all following information. How many total electrons are present? How many lone pairs of electrons are on the central atom? And how many lone pairs of electrons are on each fluorine? So, back to my slide deck and minimize that. There we go. I want to make sure that, yep, okay, cool. So SF6. Now, some of this information I'm going to just kind of pull because I remember it, but I'll also give you kind of the reference points. Now, SF6, sulfur, if you pull that up on the periodic table, or if you look at that on the periodic table, has 6, I'm going to label it VE, or valence electrons. And that should be VE. Yeah, there we go, 6 valence electrons. There are 6 fluorines, and each fluorine has 7 valence electrons. So what we're going to do to that, because we need to find out the total number of valence electrons that we're working with, we're going to say 6 times 7, and that's going to give us 42. And then we're going to say 6 plus 42 is going to be 48. 6 mentioned, 6, 7. I did. My 5-year-old would say 6, 7, 6, 7. So here we are. 48. Got 48 total electrons. Now, I know. These are the moments that I just feel old. But that's my problem, not you guys. So here we go. 48 total valence electrons. The next step that we have to do is we have to identify our central atom. Our central atom, well, what's our sequence whenever we're identifying a central atom? It is either the first atom or first element that's listed, it's the farthest to the left on the periodic table, or it is the least electronegative. Between these two, sulfur meets all those criteria. So what we're going to do is we're going to put sulfur in the middle. When we put sulfur in the middle, then we're going to put fluorine and connect it by each one of these little sticks. Could anyone tell me in the chat, each one of those lines, how many electrons does that represent? 2. Perfect. Because that is a shared pair. I'm going to draw an arrow. I'm going to say shared pair of electrons. Okay, so that's 2 electrons. Since we've got 6 of those, 6 times 2 is 12. So that's 12 electrons that I've drawn. I'm going to say 12E drawn. So 48 minus 12 is 36. We have 36 electrons left to draw. E, that should say left to draw, but my computer is running like painfully slow. Is there anything that I can close? Oh, maybe it could be all those like 14 web browsers that I have open. But I mean, I need them all because they all have links and tabs that I've opened over the course of the last month. And if I don't visit them, I'm going to forget. And that would be devastating. I do need the Wikipedia entry for the Soviet Union open because if I don't have that open, how will I know anything about the Green Revolution or the any of the other revolutions in the Soviet Union? Okay, sorry everyone. My computer's going slowly. Can everyone acknowledge with a 1 that my computer is running slowly? Okay. Thank you guys for indulging me with my commentary. Okay, so 36 electrons left to draw. Gosh, it's obnoxious. Oh, don't save that. Left. There we go. Left to draw. Okay, so 36 electrons left to draw. Okay, now this is our general structure. The first thing that we want to do is we want to place those electrons and we want to place them on outer elements. Our outer elements are fluorine. So I'm going to put 6 electrons around each one of them. Now, before I continue to the next fluorine, tell me how many electrons are around this fluorine or that are in that circle. Yes, it's 8. Next question. How many lone pairs? 3. Perfect. Okay. So I bring that up because if you see this and you say, okay, well, this pair of dots is a lone pair. This pair of dots is a lone pair. This pair of dots is a lone pair. 1, 2, 3. Then you're in good shape. Do not look at a lone pair and say, aha, this is 2 lone pairs. No, that is 1 lone pair of electrons. Think about shoes. If you have a pair of shoes, you have 2 shoes. If you have 3 pair of shoes, you have 6 shoes. So here we've got 3 lone pairs. Each fluorine is going to have the exact same number of lone pairs of electrons. They're all going to have 3 lone pairs of electrons. Now, once I do that, what I'm going to do is I'm going to go back and count up my electrons. Okay, I'm going to switch colors. I'm going to go to a green pen and I'm going to circle 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So I had 36 left to draw. I'm going to subtract 36 and I'm at 0 total electrons. So this structure right here is in fantastic shape. Now, a fair question for anyone to ask is, but wait a minute. This fluorine has 8 electrons around it, so it's satisfied. It has a complete octet. Could anyone tell me how many electrons are around sulfur? Add it to the chat. 12. Is 12 the same as 8? No, it's not. But does 12, is that a problem? Wire N to the chat. Boom! Kelly, you dropped knowledge all over the place. You don't need to pick it up. Everyone else is picking it up. So sulfur can exceed. So this structure right here is just fine. Okay. Now, that's basically question number 1. Each fluorine has 3 lone pairs of electrons. There are 0 lone pairs of electrons around sulfur. You know what, Kelly? I'm going to give you I'm going to do the point up emoji. We got the salute emoji. Well done. Okay. So sulfur can exceed. Other elements that can exceed, phosphorus can also exceed. So for our purposes, P and S are the elements that we're going to see exceed the octet. There are more that can, but these are the ones that we're going to see more than anything else. Okay, now the next thing that we need to do is, well, we need to look at this molecule as a whole. And the question is about each one of these bonds. Now, if you had the electronegativity values, you would see that fluorine has an electronegativity of 4, and sulfur has an electronegativity of about 2.5. So our electronegativity, I'm going to label it as delta En, our change in electronegativity for this bond right here. We are looking at fluorine is 4.0. Sulfur is about 2.5. So our electronegativity difference there is 1.5. Now that, if you remember, 0, our difference in electronegativity, our delta En, if that difference ranges from 0 to 0.5, that bond is considered nonpolar. If it is 0.5 or 0 to less than 0.5, it's nonpolar. If it is 0.5 to 2.0, then it is polar covalent. And if it's 2.0 or greater, then this is an ionic bond. Question, where did you get the numbers from? Can I get that from the periodic table? If you're referencing the electronegativity values, these values right here, I will provide those in the question, but they're also in an there's a separate display of the periodic table that shows the electronegativities. Um, so does that answer your question? Okay, cool. But I would give you these values in this question if it were on an exam or something. Okay, so this difference of 1.5 classifies this bond as a polar bond. Now the question is, well, is this bond or is this molecule a polar molecule? And to answer that, you can look at each one of the bonds and say, oh, well, each bond is a polar bond. And if you did that, you'd be right. Each bond is indeed a polar bond. But then, if we're asking, is the molecule polar? This is where I always like to use an analogy of a tug of war. Well, what we are looking for is we're looking to see, is anyone going to win this game of tug of war? And in order for a game of tug of war to be won, one side needs to be stronger than the other side. Now, with that in mind, when we talk about one side versus another side, and we look at this molecule, we are not comparing this fluorine as one side and sulfur as another side, but instead we're looking at this fluorine as one side and this fluorine as the other side. Another way you could look at that is to say, okay, well, basically, is the electronegativity difference in this bond greater than this bond, or this bond, or this bond, or this bond, or this bond? Is there some sort of imbalance in this molecule? And I'm going to go ahead and say molecular imbalance. And another way that you could think about that, or another way that I'd like you to rephrase it, is to think about symmetry. If the molecule is symmetrical, and let me actually, if there is a game of tug of war where you have symmetry in that game of tug of war, is anyone going to win that game of tug of war? Add a Y or an N to the chat. No. Those two sides will just fight it out and they'll basically give up at the exact same time. So if you have molecular imbalance, or if you have a game of tug of war where there is an imbalance, will somebody win that game of tug of war if there's an imbalance? Yeah. So you could look at molecular imbalance as a sign that there is no symmetry. I think that's like 3 M's in symmetry. Symmetry. Okay. So now my question for you guys is just visualize this molecule. And that really kind of looks like what is a sand dollar? Um, Tell me, Do you see any imbalance in this molecule? And please don't use my drawing as a representation as like, oh, well, you drew the dots on this side, because that's probably just me being not a great drawer. Yeah, there is no imbalance here. If you got your plane of symmetry, if you kind of cut it down the middle, whenever I say plane of symmetry, it makes me feel a little bit smarter than I am. What I'm really asking is if you got a knife and you cut this molecule right here, what do you have on each side? On this side, I've got three fluorines. On this side, I've got three fluorines. Well, what if I cut it like this? If I cut it straight down the middle, well, then I've got I've got half of some fluorines on this side, and then I got the same number on the other side. So I've got a symmetrical molecule. So if there is a molecular imbalance and there is no symmetry, in that case, you have a polar molecule. Again, I like to think about that game of tug of war. If you have an imbalance, if you have no symmetry, then is somebody going to pull, Pull, and win that game of tug of war? Yeah. But if you have perfect symmetry, then you have no polarity. So no pulling, Pull, that's going to win. Could you give me a 7 in the chat if that makes some sense? Great, 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 great. Being able to do this is going to be valuable. Being able to identify the correct Lewis structure is going to be valuable. Now, I don't have any questions on the practice exam that show you a Lewis structure. There are questions that ask you about a Lewis structure, kind of asking you and making you visualize it. But I did that because you have an infinite amount of time on that practice exam. There will be some questions on the exam where I'll show you here, here, and here. Here's three different models for this either element or for this molecule. Select the right one. And so then you'll have to think about, oh, well, what are the rules that I know? And how do I draw a molecule? Now, wait, so since it's symmetrical, it's nonpolar? Yes, I'm happy that you asked that. And I'm going to go ahead and add that important detail. Symmetrical, or I'll say symmetry, equals non-polar. And then I'm also going to add symmetry equals, I'll say it as balance. And actually, I'm going to go ahead and say balanced tug of war equals nobody wins. Okay, so that's effectively, oh, rats. You guys remember a few minutes ago when I was closing all my browser windows? Yeah, included in that was my homework that I was using as a reference to look at all this stuff. So here we are. So now I got to go back to Canvas. That means I've got to log in. It's no big deal. I might have to. And you know what? I'm really proud of myself for not mouthing or saying my password aloud as I was typing it in. Good job, Joel. You're growing up. Usually that's the bad habit that I have where I'm like, "Duh, duh, duh," and I say my password. So there's one of my, okay, where is it? Homework. That was two. Um, okay, now we're going to look at homework three. Homework three asks you for this molecule, NH3. Now, if we were to draw this, which I'll go ahead and go through that, in the interest of time, I'm not going to do all of homework 3, 4, 5, and 6. I'm going to, get the high points of it. So homework number 3 asks you about, well, what's the Lewis, or draw the Lewis dot structure of this. Okay. Nitrogen rolls in with 5 valence electrons. Hydrogen, each one of them rolls in with 1. So we got 5 plus 3 equals 8 valence electrons. So our central atom, well, it's the farthest to the left, least electronegative, or it's the first one listed. Well, the first one listed is nitrogen, and hydrogen always serves as a little bit of an exception for things. Specifically, like hydrogen only likes to have two electrons around it. So I'm going to go with nitrogen as my central atom. Then I'm going to connect the dots between nitrogen and hydrogen, nitrogen, hydrogen, nitrogen, hydrogen. Based on these shared pairs of electrons, I've drawn six electrons. So I have two left. Where am I going to put those two? How about here? No, that doesn't make any sense because this hydrogen now has four electrons. Is that good? No, that's bad. Hydrogen likes to have two electrons, so I'm going to erase that. I'm going to put two electrons there. How's that nitrogen feeling right about now? That nitrogen says, okay, well, I've got three shared pairs of electrons, so that adds up to six. And I've got this one singular lone pair of electrons. Ooh, I've got eight electrons around me. I'm feeling pretty good about things. So this is our Lewis dot structure of NH3. Now this question is asking us about the geometry. And for the geometry, we used the AXE system. Now that AXE system, A is our central atom. And what we want to do is we want to look at, well, what is surrounding our central atom? X is representing any adjacent atoms. They don't have to be the same. If this was, let's say, rather than NH3, it was this. Our notation would still start out A, X, and there are three adjacent atoms. So we'd put a subscript of 3. Now, for the sake of the problem, I'm just going to erase that and put an H back there. It would still be AX3. Could you give me a Y or an N to the chat if you follow that this subscript 3 represents the number of adjacent atoms and has nothing to do with identity or anything like that? Great. So then the E represents, actually, let me change that line. I'm going to go ahead and draw. A represents the nitrogen. E represents the lone pair of electrons. So we're going to say AX sub 3 E. You don't write it very often, but if you want to, and if it helps you keep things straight, you would look at it and say, okay, well, AX3E1. You could also just say AX3E. The 1 represents the number of lone pairs of electrons. So E specifically is lone pair of electrons. X is adjacent atoms, or I'll just say other atoms. And A is our central atom. Okay. Now, if you were to compare that to something like CH4, well, CH4 has notation that is AX4. And CH4 looks a little bit like this. Oh, Victor, that's a great question. Is E for all lone pair of electrons or only on the central atom? Only on the central atom. Thank you for asking that. Because all of this AX system is defining what's around the central atom. So the A here is only caring about that central atom. Does that make sense? Wonderful. Thank you very much. That's a great question. So CH4 is a nice example of, well, AX4. Similarly, CH2F2. Well, that molecule would look like this. We've got fluorine, hydrogen, hydrogen, fluorine. Our notation for that would be AX4 because it's got 4 adjacent atoms. Now, the fact that fluorine has lone pairs of electrons doesn't really matter that much for this question. Okay. Now, this question goes on to ask you about do the same sort of thing, like show the electronegativity difference, and is this molecule polar or nonpolar? So when you look at this, one of the things that I want you to think is, let's see, and give me a P for polar and an N for nonpolar. I'm going to give you a plane of symmetry. Actually, no, say S for symmetrical and A for asymmetrical. On this side and on this side, is it the same thing? Would you put an S for, yeah, that's symmetrical. Both sides are the same. I'm not really going for a trick question or anything like that. Yeah, I would say that on each side, you've got kind of the same thing. Okay, now let's change our axis of symmetry. Let me erase all these. If I did this, is it symmetrical? Is what's on top the same as what's on bottom? A for asymmetrical or S for symmetrical? Or N for no, it's not the same. You're right. Okay, so whenever we were talking about these definitions down here, basically what you're looking for is if there is any asymmetry in a molecule, you're going to classify that molecule as polar. So how would you classify this molecule, NH3? P for polar or N for nonpolar? P, polar. Spot on. We have one line. Oh, well, if we split it this way, it's the same. Okay, cool. But when we do this, oh, that's where it's different. So there's asymmetry in this molecule. All right. Now, next up, here I'm going to show you a picture of my youngest child. That's him. Here we go. There's smiling. Okay. Now, after that, does anyone want to guess how old he is? That's right. He's 6, 7 years old. Not really. Ha ha ha. He's in like a week, he'll be 8 months. Okay. Oh, dang it. Okay. So, word, word. Um, he's got lots of like coughing that he's doing now, which I think the pediatrician just referred to as the daycare cold. They're like he goes to daycare and it's like yeah, it's the daycare cold. I was like, yeah, I kind of get that one too a little bit. Okay, now homework number 4. This is asking about prefixes or suffixes, no, coefficients, and any other notation. Question number 1 on homework number 4 reads, how many atoms of H do you have if you have 3 moles of H2O? Okay, how many atoms? And this is also asking about moles. So you have 3 moles H2O. And how many H atoms? Okay. Now, one thing that's important to know is if we have one molecule of H2O, we have two hydrogens. Could you give me a Y in the chat if you agree with that statement? Coffee grounds. Ugh. Okay, good. I'm happy to see that. Now, let's say that I have 3 molecules of H2O. I mean, this is just multiplication. We have 3 molecules. We have 6 hydrogens. Done. Great. Okay. What I always like to do is I like to take these sorts of statements and bank them. And then I like to go on and I say, okay, if I have 1 mole of, let's say anything, if I have 1 mole of, I'll say H atoms, then I have 6.02 times 10 to the 23rd atoms. And what I'm underlining right here, I could replace that with anything. I'm gonna say H atoms. Um, and that would fill in this right here. If I said I have 1 mole of pencils, then I would have 6.02 times 10 to the 23rd pencils. Okay. Is everyone good with that? Give me a 1 in the chat if you're good with that. Okay. Now, what I want to do is I want to take that statement and I want to say, if I have 1 mole of H2O, well, H2O, that's a molecule. So it would be best if I wrote 1 mole of H2O molecules, right? Give me a Y or an N to the chat if it would be valuable, a good reminder for me to write molecules here. Okay. So I've written molecules. How many, if I have 1 mole of H2O molecules, I have 6.02 times 10 to the 23rd H2O molecules. Give me a Y or an N to the chat if you follow that. Okay. Now, what I need to do is I need to take this information right here and marry it to this information right here. Because I know 6.02 times 10 to the 23rd. This number right here, and I would have no problem writing this on my note card just as like a little reminder. Because I remember whenever I took my first chemistry class, I saw that number and I was just like, that number is such a large number that it doesn't mean anything to me. And it doesn't make any sense to me. So what I started to do whenever I would get my tests is I would write, okay, 6.02 times 10 to the 23rd. In order to write that number out in complete notation and to give me perspective on it, I would say 602 and then I'd write 21 zeros. That's 6, 12, 15, 18, 21. These two are the same number. And now, before I do anything else, I want to ask you, is this number right here more than 3? Give me a Y or an N to the chat. Is it more than 5? Y or N to the chat. Yeah, it is. So that sort of exercise was always helpful for me because I would then be able to take this information in this box right here and I would say, oh, I have, let's see, I'm going to put my commas. This many molecules of water. If I have 1 mole of water, I have this many moles of H2O molecules. Now, the question asks me, if I have 3 moles of H2O molecule, how many hydrogen atoms do I have? Well, I need to multiply this by, what would I need to multiply this by to come up with my final answer? I'd multiply it by 6. The reason is because I need to dissect. I need to do what I did right here. I need to dissect each molecule. Because I would say, okay, well, I have 3 moles of water, so I'm going to multiply this by 3. That's going to give me, well, that's going to give me the first part. That's going to say I have that many molecules of water. Now, what do I need to multiply it by after that to get the number of H atoms? Perfect. I need to multiply it by 2. Does that make sense? Give me a Y or an N to the chat. Okay. This is a little bit of a lengthy exercise, but it's worth your time to do it. To write this out, I think is worth your time because then you can say, okay, well, I'm going to compare this question to this number because I need to. And I'm also going to include this information because then it's helpful for me to think about, okay, well, what does one molecule consist of? What do three molecules? Well, if I have one molecule of H2O, that means I have two hydrogens. If I have three molecules of H2O, I have I have six hydrogens. I know that also in my experience teaching and, well, taking chemistry, it was really helpful for me to think about things that were tangible. Like if I have 1 mole of cars, I have 6.02 times 10 to the 23rd cars. Okay. How many wheels? How many wheels do I have? Okay, well, each car has four wheels. So I take this right here and multiply, or sorry, I take that 6.02 times the 10 to the 23rd and multiply it by 4 because each one of those cars has four wheels. Each one of these H2O molecules has two hydrogens. Okay, could everyone, yeah, so that's kind of the continuation of that homework 4. Homework 5, write a balanced chemical reaction between sodium phosphate and magnesium nitrate. The question, where does 6.02 or 6.02 come from? The 6.02 comes from our definition of what is a mole. So a mole is, it's just like a dozen. How many are in a dozen? If you have a dozen eggs, you have 12 eggs. If you have a dozen cars, you have 12 cars. 1 mole is the quantity or the number that scientists and chemists use to think about how things take place in chemical reactions. I hope I answered that question adequately. Okay. Now, I'm actually going to jump on to question number 6. And the person who asked me the most recent question, could you just confirm why or and yes, I follow that. Um, Homework number 6, the first question is, using the balanced chemical reaction shown below, calculate how many grams of water will be produced if 2 moles of CH4 react with 4 moles of O2. Okay, so this chemical reaction is CH4 plus 2O2 yields CO2 plus 2H2O. Now, it's always helpful to not necessarily like as a check, because if I tell you that a chemical reaction is balanced, it's going to be balanced. But I think that it's always a good review to look at a chemical reaction and say, okay, well, what do I have? I've got hydrogen, carbon, and oxygen. I've got 4 hydrogen, HCO. We're on number 6. I'm jumping ahead to 6 just so I can get this one in. If I have some time, I'll jump back to number 5. Thank you for asking. We are on homework number 6. Okay, so I'm going to put a check mark by my atoms as I kind of count them off. 4 hydrogens. Well, this 2 applies to everything, this H2O. There's 2 hydrogens, so I've got 4 hydrogens. So the 2 coefficient impacts that hydrogen number. Carbons. And now I'm going to go ahead and put a check mark by that. Carbons, I've got 1 carbon, 1 carbon. Oxygen, 2. Here's 2. And, oh, that 2 accounts to this. So I've got 4 oxygens on each side. So my chemical reaction's balanced, but this also just echoes that we need to have the same number of each atom on each side. Erase, 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 erase. Okay, so we're balanced. I'm going to erase this as well. Now, this question goes on to ask, it asks us, well, how much water, how many grams of water will be produced if 2 moles of CH4 react with 4 moles of O2? Okay. So what I want to do is I want to say, okay, well, my ratio of CH4 to O2 is a 1 to 2. But I actually have 2 moles reacting with 4 moles. So that's again kind of a 1 to 2 ratio. Now, what I'm interested in and what I want to look at is I would say, well, if I have 2 moles, CH4, like the question says, I'm just going to pick one thing. How many moles O2 do I need? Well, then what I'm going to do is I'm going to say 2 moles CH4. And then I'm going to look at my ratio. So what I'm doing is basically reading the question, but I'm stopping at the point where it says 2 mole after, sorry, I'm stopping after CH4. How much water will be produced if 2 moles of CH4 react? That's where I'm stopping because what I want to do is I want to be able to answer this question right here. How many moles of O2 are needed? I'm going to put the ratio that's in my balanced chemical reaction. 1 mole CH4 reacts with 2 moles of O2. So here is my ratio of reactants to one another. And whenever I do this, I'm going to multiply, or what I'm aiming to solve for is how many moles of O2 are needed for 2 moles of CH4. I'm going to say 2 times 2 divided by 1 is 4 moles of O2. Now, I'll go back. So I'll go back to my question. My question says, if 2 moles of CH4 react with 4 moles, okay, well, how much O2 was needed for 2 moles? Well, 4 moles. Do I have that? Yes, I do. So I am good. So the next thing that I'm going to do is I'm going to set up a ratio that looks like this. I'm going to now just compare my CH4 to my H2O. Can everyone give me a 9 in the chat if they follow what we've done so far and are good to set this up, and a letter L in the chat if, wait, I'm confused. Okay, if you're hesitant to put an L in the chat, really what we did was we just had to confirm. This is an exercise in confirming we had enough of each of our reactants. And now we've just selected one of them to say, all right, well, we can move forward to that one reactant. So I just selected CH4. I could do the exact same thing with O2, but I'm going with CH4. And what I'm going to do is I'm going to say, all right, well, I have information. What do I have? 2 moles CH4. Moles CH4. Okay, that's the first part of my setup. 2 moles of CH4, and now I'm going to put my ratio. But my ratio is going to be CH4 to H2O. And whenever I do this, I'm going to say 1 mole CH4. Could anyone tell me what I need to put in the top here? And please provide all of the information. What information do I need to put in the top half of my ratio? I'll give you a little bit of a hint. Perfect. Maddie and Zach, you are spot on. Great job. So I'm going to say 2 moles H2O. I'm going to erase this. I'm going to say 2 moles of CH4. This and 1 mole CH4, those will cancel. So now I'm going to say 2 times 2, because that would tell me the total number of moles of H2O that I'm producing. But this question isn't asking. Kelly, you're right. We would be making 4 moles. But this question is asking how many grams of water. So now what I need to do is take this one step further. And now I'm going to say 1 mole H2O. And above that, I need to put the mass. The mass is going to be from the periodic table. The mass for oxygen, I just remember this, is 15.999. And I'm going to call it 16. I've got two hydrogens. Two hydrogens, they're 1 gram per mole each. So I'm going to add 2. Is everyone good on the 16 and the 2? Add a Y in the chat if you follow that I pulled those from the periodic table. I just kind of have them in my head. But if you don't, you'd get them from the periodic table. A Y if you're good, or an R if, wait, where did that come from? Okay. So now what I'm going to do is I'm going to write 18 grams of H2O. So now I can cancel some things out. Moles of H2O, moles of H2O. That is what I'm looking for, is grams of H2O. So I'm going to say 2 times 2 is 4. Times 18 is 72 grams of H2O. And that is the answer to that question. Could everyone give me a emoji in the chat if you follow all of that? Great. Great. Okay. Now I'm going to go on to the next question. The next question is asking about the exact same chemical reaction. The chemical reaction is CH4 plus 2O2. I'm going to write this down. CH4 plus. Yes, I will be posting a recording of today's lecture. When you asked, I got a private message asking you that, and whenever I see that question asked, I have a moment where like all the blood rushes out of my head, and I'm like, my stomach sinks. Did I remember to record? And I did. So we are good there. CO2 plus 2H2O. Okay, this question right here is a next level question. This is a really challenging question. And that's why it's a homework question. Would you get something like this? You get something close to it. But if this were on an exam, this would be like 5 separate questions. Maybe not 5, but like 3 or 4 separate questions. This question says you have 44 grams of CH4 that react with 44 grams of O2. And it asks you to produce or identify which is in excess and which is limiting. Now, to answer this question, what you need to do is go through a series of steps. First of all, what we need to do is we need to find out how many moles, we're going to use this CH4, how many moles of O2 are needed to completely react with 44 grams of CH4. Now, the way that we'll do this is we'll say 44 grams of CH4. Then we're going to say, okay, well, how many grams of CH4 are in 1 mole of CH4? And the next thing that I'm going to fill in here is going to be coming from the periodic table. So C has a mass of 12, and there's 4 hydrogens. Each one of them has a mass of 1, so that'd be 4. So 16 grams of CH4 is 1 mole of CH4. Could you give me a Y or an N to the chat if you're good with that? And that this information came from the periodic table. Great. Now, the question I'm looking to ask is how many moles of O2 are needed for this? Well, I know from my balanced chemical reaction, 1 mole of CH4 reacts with 2 moles of O2. And so to answer this question right here, I'm going to say 44 times 1 times 2. I'll plug that into my calculator. 44, basically 44 times 2 equals 88. And then I'm going to divide that by 16. 5.5 moles of O2. Could everyone give me a Y or an N in the chat if they followed this math that we've done so far? Okay. Now, an important point is we're not done. What this tells us is that if we want to react all of our our 44 grams of CH4, we need 5.5 moles of O2. Now, a fair question is, well, do we have 5.5 moles? I don't know. I don't know yet. But do we know how much O2 we have? Do we have a measurement of the O2 that we have? We do. We have 44 grams of O2. So what we're going to do is now we're going to find out, well, how many moles of O2 is this? Does everyone follow that? Give me a Y or an N to the chat that now we are using our second quantity and we need to convert that from mass to moles. Okay. So to find out how many moles this is, what we're going to do is we're going to say 44 grams of O2. Well, okay. If you look on the periodic table, you'll see that O, or oxygen, has a mass of 15.99, which I'll call 16. So O2, that means 2 oxygens, 32 grams of O2 is 1 mole of O2. Can you give me a Y or an N to the chat if you follow that? Now what we're going to do is we're going to say 44 divided by 32. And we're going to see that we have 1.375 moles of O2. So what we're looking at here is we are saying, okay, if we have 44 grams of CH4 and 44 grams of O2 reacting together, that means that, well, if we want to consume, how many moles of O2 are needed to consume? Okay, I got a private message question that, where's the 32 come from? This is from the periodic table. How many moles of O2 are needed to consume all of the CH4? How many moles? We need 5.5 moles of O2 to completely consume it. But do we have 5.5 moles? Add a Y or an N to the chat. Do we have 5.5 moles of O2? Remember, this is the amount, this is the mass of O2 that we had. And that told us we only have 1.375 moles of O2. Okay, private message question. I know I'm getting ahead, but just to confirm, this means we cannot do this reaction balanced with only 44 grams of O2. What this means is that this reaction will take place and there will be excess CH4. So there will be some CH4 that's left over. So all of the O2 will be used up, but there will be some CH4 left over. This is kind of like The hot dog plus hot dog buns sort of question. Like I said, this is a question that would be like 8 steps long. And sorry, it would end up being like 8 questions. So you'd be working through individual steps, multiple choice steps to answer this one. So the point is, if we react 44 grams of CH4 and 44 grams of O2, a reaction will take place, but there will be CH4 left over, which means that CH4 is excess and O2 is limiting. Okay. Make sure that you do the survey tomorrow by 5 p.m. If you want, I'm stepping away, but I'm going to be in my office hours in about 10 minutes. I'm going to get some more coffee. Um, Thank you guys very much for coming. If you've got any questions before the exam, I'm glad to answer them. And I hope you guys have a great Tuesday. And also, if you are leaving and you're like, oh my gosh, this is a really hard problem, you're not going to have a test that's like 40 questions of this. Okay? So don't stress about this so much. Deal?